Hey everybody, welcome back. And to whoever doesn't know me, my name is Mikhail. And today I'm gonna make a video about audison amplifiers and 3D scanning, because these amplifiers, I'm gonna use them on a side-by-side, but they are not waterproof. So I need to 3D scan them. I need to, another day, design an enclosure to make it waterproof. So here we go. So yeah, look at all those connections over there. It has a speaker in, speaker out, pre-in, levels, subwoofer control. So this one does not have DSP in it, but the bottom one, the 8-channel, so this is a 6-channel, this one is an 8-channel. This one is a DSP amplifier. This one has a USB connection port. So you could control everything from your computer. You could control this amplifier will control that one. But there's just so much going on here. There's a DSP out, optical in. So I'm going to run an optical cable on this one. So this amplifier is just insane. I mean, the 6-channel is gonna control the subwoofer. So I'm gonna, when you bridge the 6 channels, it becomes a 3-channel. And it sends like 430 watts to a subwoofer. So I'm gonna get a kicker with a passive radiator installed in the back. And then the other 2 channels are gonna be for the tower speakers right behind my head. But the other amplifier is gonna power the 2 horns in the front. Then I got 2 subwoofers. Well, they're mid-bass. They're 8-inch. They're on the bottom. Also, they have a passive radiator. I couldn't make a video of the passive radiator because it's just like there's no room in there, but there's actually a passive radiator. And then in the doors, I'm going to have 2 6.5-inch speakers. So that's a total of 6, 7, 8, 9 speakers that those 2 amplifiers are going to run. And I just, probably in the next 2 weeks, I'll be ordering all the wires that I need to start hooking up speakers. Now that my computer, everything is in the garage, finally, I could start programming the sound of this car, hopefully sometime next week or in the next month or so. But if you guys want to see all that, definitely subscribe, and you won't miss anything that I'm doing. So now I'm going to explain to you the process of 3D scanning. So this is what it looks like, and this is by a brand, Shining 3D, and this is their free scan combo. I love it that it's pretty tiny, but the accuracy of this thing is insane. We're talking about 0.02 of an inch accuracy on this. It's more than what you could probably get with a caliper. I mean, it's on a micro level. The calipers can only be as accurate as this laser. I mean, I've scanned stuff, and when you measure it, it's just what it is. That thing doesn't make mistakes, but it's one of the best scanners out there. So a lot of times when there's a big surface on something, you want to install these stickers. I call them mile markers, because the lasers, they kind of understand where it is located based upon these dots. So typically I grab one of these. I think I'm going to start off with the main one here. This is the most expensive one, is the 8-channel. I think this thing is $1,600. But I'm gonna probably, because it's not so huge, I have a lot of stickers on this rotating table, and then I also have these angled parts, and this kind of helps me scan at a 45-degree angle, because when stickers, you got to point directly above it. But if you want to try to grab the side of something, then you got to get these angle parts. So I think I'm gonna put maybe like 4 here. Then I'm gonna flip it around so I could scan the back end. I'm gonna probably put 4 here as well. I just put 5, one in the middle. Then I want to put some on the sides. That way I could rotate it and align. Because you could use these markers for alignment, because a lot of times you got to do at least 3 scans and then you got to glue them together on the software, because you can't just scan every side. You have to rotate it and then reposition and then scan again. But I'll get to that in a minute after I get these stickers on. But sometimes you start a project and you might realize something. Like right now, this is what I'm looking at. If this edge was flat but it's curved, I'd be able to set the amplifier down like this. But if I do it, it's gonna be a little bit wobbly. So I have no option, because if it was this way, I'd rotate it and get every single side like this, the top and 3 sides. Then I'd only have to rotate it once to get this side. But I'm gonna have to do it another way, and that's this way. And then I will place these, at least 3 on each corner, like that. And then I'll push them so you could kind of see them from that angle and from this angle. And I have my scanner set up to where the scanner needs to at least see 3 markers for it to actually scan. Otherwise, it will stop scanning. So when you rotate it at an angle, I think this is going to be pretty good. So now I'm starting a new project group, and I called it Audison 8-channel. So right now, before I actually start scanning, I got to do a scan global markers. So I turn it on, and then I just move it around, and what it's doing right now is just scanning all the markers. It wants to recognize and save all of them. And you typically do this actually, and then you kind of move it to the side, and then you'll start scanning all the markers that are on the side. Once this process is complete, you stop scanning, then you push a button here, Global Markers Optimization. So it's gonna process all the data and make sure that they're 100% accurate and synced together. So after that's done, you could actually start scanning now. So on an object this big, I'm gonna try to do accuracy of maybe 0.1 of a millimeter. I think this should be enough for what I'm doing. It's probably even too much. So I think I'm just gonna go at a 0.2 of a millimeter. If I do the craziest accuracy, which I don't need it, this is not a mechanical part, there's gonna be nothing moving in that engine, like you need something better. But on something like this, just for rough design, 0.2 of a millimeter accuracy is perfect. So let's get moving. Once I scan just a little bit, I want to delete the plane, because right now you could see on the computer it actually grabbed some of the table. So what I'm going to do is cut plane by markers. So you just got to select the markers that are located around the parameter of the thing. create plane. And apply. So there we have it. Now I'm gonna scan, and I shouldn't have more than what I need. It should just be scanning now, just the amplifier. And as you can see, it's close to almost done. I just gotta kind of scan everything at an angle because of these holes. I really wanna grab the holes there. Now I could rotate it, and my 3D scanner with the angle markers is doing a good job right now scanning the sides. So when I designed this enclosure, I think I got to make a valve, because when these amplifiers are going to heat up, typically there might be pressure buildup inside. So I'm going to make a valve where it kind of allows pressure to come out of there. So I think I completed one side. So after that's done, that process pretty quick. After that's done, what I need to do is create a new project. Now, once I created that new project, what I could do is flip it around now. Well, pretty much wrapping up on that one. And now, all I gotta do is combine those together. So you go to alignment, you select both projects, and you have to align the sides. So you want to rotate these amplifiers so they kind of are looking the same way. And then manual markers alignment. So what I do is I select markers and it gives it numbers. So 1, 2, and then I'll rotate to the side. On this side, I'm just going to select 1. And then on this side, I'm going to probably select 2. Now I'm doing a lot more than I should. I really technically only need to do just 3, but I'm just gonna do 6 this time. And it's just gonna align them together. So there it is. Looking good. Looking really good. So yeah. I think this is usable data, and that is, I want zero optimization, so I don't want AI to fix anything. I just want it to be standard. If there's any holes, I don't want it to correct anything. That way I know I have something that's true accuracy. Nothing I don't need AI on anything. So remove spikes, sure, I do that. I don't even remove the holes. So I just leave it be, because what the process is going to do, it's going to delete the markers, the stickers, but then there's going to be like a hole there. But I don't even like to do AI on that, so I just kind of leave it as it is. So while my computer is doing its processing, I wanted to explain why I picked this amplifier, Audison. It's an Italian brand, and in 2024, it won the DSP Amplifier of the Year. So the technology behind the DSP on this is nothing like anything else out there. So that's why I'm using it. I don't care that it's waterproof or anything. All I care about is the quality of the amplifier, and that's what I'm willing to go as far as it takes to install this on my side-by-side. I'm gonna make, even if the case to make it waterproof, it will cost me thousands of dollars, I'm still gonna do it. I mean, I've already paid $1,700 just for one amplifier and $1,000 for the other. So I'm already like $2,700 into just in the amplifier. So I'm not gonna stop there. Even if it costs me $5,000 by the time I set it into my car, I'm still gonna be happy, because there's gonna be no amplifier out there better than this. And there it is, ready to start making an enclosure where that's gonna sit in. So after I do that and I figure out all my wiring, then I'm gonna rescan it when it's plugged into everything. That way I could understand naturally which way the wires are going to want to sit. So whenever I create ports, I want it to naturally go into the holes to come out the other end, because I haven't figured out every single wire. I know I'm going to use an optical, and then I know a couple other things, but until I get there and actually do it. So that's why designing is going to be for later. So that pretty much wraps it up for this video, and I appreciate you guys stopping by again and watch my videos, and I appreciate, thank you for the ones that push like. Definitely gets me motivated to keep going, and I know at least I'm doing something for somebody. This is not just for me, because eventually one day this stuff will be in one of your cars. So you're not just watching something that I'm doing for myself, because right now, yes, I'm doing everything for myself, but believe me, I want to have better than anybody out there, but at the end, you're gonna have it too. So, talk to you later.